Ever wondered why a thrown ball, a bridge cable, or a fountain of water all curve the same way? That curve is called a parabola. That curve comes from a quadratic equation, one of the most important concepts in grade 10 math. Let's break it down. A quadratic equation is written as ax squared plus bx plus c equals 0, where a, b, and c are numbers and a cannot be 0. If a were 0, the x squared term disappears and it's no longer quadratic, just a straight line equation instead. Quadratics aren't just theory. They describe bridge arches, satellite dishes, and how objects fall under gravity. Solving a quadratic means finding its roots, the values of x where the equation equals 0 and the curve crosses the x-axis. There are three main ways to solve a quadratic: factorization, completing the square, and the quadratic formula. Let's try each one. Let's solve x squared minus 5x plus 6 equals 0 using factorization. We need two numbers that multiply to 6 and add to negative 5. Those numbers are negative 2 and negative 3. So we rewrite the equation as x minus 2 times x minus 3 equals 0, giving us two solutions. Setting each bracket to 0, we get x equals 2 or x equals 3. Those are the roots of the equation. But not every quadratic factors easily. When that happens, we turn to a formula that works every single time: the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Let's try x squared plus 2x minus 3 equals 0. Here, a is 1, b is 2, and c is negative 3. Substituting into the formula gives us x equals 1 or x equals negative 3. Same answer as factoring, just a different path. The part under the square root, b squared minus 4ac, is called the discriminant. It tells us how many real roots exist. If it's positive, 2 real roots. If it's 0, 1 repeated root. If it's negative, no real roots at all. Every quadratic equation traces this same U-shaped curve, and now you know exactly how to find where it lands. Remember, factorization, completing the square, or the quadratic formula. Pick your method, practice a few problems, and you've got this.